Hey, what up, squad? Mr. Herr here, making a video for lesson 7.3, which is page 11 woot woot, in our books. Let's do this thing. Okay, today we're going to talk about similarity postulates, something like angle, angle for similarity, aka angle, angle, similarity right there. So if two angles of one triangle are congruent to two angles of another triangle, then the triangles are similar. That means triangle TRS, single arc, double arc, no arc, must be similar to triangle, my bad, PLM, because we have two congruent angles. That's all you need for similarity. Okay, same idea if you have side, angle, side. If you have one angle that is congruent to another angle, and then the sides including the two angles are proportional, then the two triangles are similar. The same can be true for side, side, side of similarity. If you can spell similar, which I can't, my bad. Okay, so if the corresponding sides of two triangles are proportional, then the two triangles are similar. Eventually, in fact tomorrow, we're going to talk about how we use this in proofs. Don't panic, we're not going to do any proofs today, especially with me not being around. Okay? But we will do a little bit of looking here. Using AA, if MX is perpendicular to AB, why the triangles are similar, right? The similarity statement. Okay, well, if MX is perpendicular to AB, that means angle AXM and angle BXM are right. Not only that, but if that's the case, because of the definition of perpendicular, no, we won't write that out, but then AXM must be congruent to angle BXM because of the right angle theorem. Again, we're not going to write that out. Then we have angle, angle. Therefore, triangle AMX is similar to triangle BKX. That's all we had to write right there, because we have congruent angles here and here, woot woot, woot woot, and there. Go team. Explain why the triangles must be similar. So right here, what we want to do, we have vertical angles, check, around ZVY and XVW. Then we want to prove that we have proportions. So we'll go our smaller side of our small triangle, 12, to our smaller side of our larger triangle, 24. Similarly, larger side of small triangle to larger side of big triangle. Both of those reduce to 1 to 2. So because we have angles included between sides that follow a ratio, we can conclude that these are similar. Specifically, triangle ZVY is similar to triangle XVW. Okay? Woot woot. Go team. Okay, let's give this thing a flip. I'll try to keep going as fast as we can. Okay. Here, number 3, we can use proportions to show that we can solve for an unknown. Here we want to know how tall a tree is. Well, because we can say, wait a minute, that's a reflective angle. We have angle, angle for similarity. Those must work. If you're saying, I don't see that yet, don't worry, we'll build that up tomorrow. So we're going to set this up. Height of the small triangle over height of the base must be equal to, be consistent, remember? Be consistent in math, be consistent in your life. So height of the small over height of the height of the small over base of the small must be equal to height of the large over base of the large. Set it up and go. You don't need to be a math teacher. You realize very, very quickly X is 40 feet tall. Okay, go team. In example 1, we kind of answered this. Yes, because of AA for similarity. Okay. Number 2, let's keep rolling because I know time's a wasting. We want to find a reason why they're similar. So we have 8, which would match up to 6, another 8, which matches up to 6, and then a 12, be consistent, Mr. Herr, which matches up to 9. If I'm saying why be consistent, because I was going top to bottom, top to bottom, top to bottom, be consistent, no diggity, no doubt. Sure enough, all of these reduce to 4 to 3. So yes, similar, because of the side for similarity. Okay. And in fact, we could call this triangle EGF is similar to triangle BCA. All right. Last one, another similar triangles things. Think proportions. They used to use this all the time when like felling trees and whatnot. If you're saying, what's that mean, old man? That means when they cut a tree down, they want to make sure it's not going to hit something close to it. If they can't measure the top of the tree, they would think proportions, right? So again, just like example 3, be consistent in your life. Height of the person over shadow of the person, 6/4. Well, then it's height of the cactus over shadow of the cactus. Go team. Do a little bit of quick math, and the next thing you know, what do we get? 4x is 54. Divide both sides by 4, and I'm only pretty sure that x is 13.5 feet tall. Okay, go team. So hopefully you filled in all those notes. What I would like you to do is 2 for the price of 1. On page 13, tell me whether or not these are similar. So like here, number 2, we have congruent sides there and congruent angles there, also congruent sides. So that means whatever ratio 1 tick to 2 tick would be there, it'll be the same ratio here. So this is yes, because side, angle, side for similarity. Okay, did that one together for you. Here we have 95 and 30. You can do a little bit of quick math and realize that our missing angle is 55. So we have 95, 55, 30. Here we have 95, 55. Ooh, this is yes, because angle, angle for similarity. Okay. Same deal here in 3. Yes, because my fault. Angle, angle for similarity. I won't do them all, I assure you. But I do want to find one that doesn't work. Just in time. Here in 4. Here we have a small side 4 to 8. Here we have another side of 6 to 10. Unfortunately, 4 to 8 is 1 to 2, where 6 to 10 is 3 to 5. Those are not equal, so that's a big old no. Okay, so that's the plan for 13. Page 14 is very similar, only we'll do a little bit of why they're similar up top here. Down below, we'll set up proportions and go. Okay, what I mean by that is, like here for number 7, we have across from the angle 5 over base of 6 equals across from the angle x over a base of 9. Cross multiply and go, and the next thing you realize, x is 7.5. Okay? So pages 13 and 14, I'll kick the keys, you know how I roll. Have a great one. See you tomorrow. Peace.